on, and we are live. This
Pepper.
is our final lesson of this math chapter, and we're going to end it off with a problem solving lesson, which will allow us, guys, to practice adding and subtracting with our mixed numbers, but we're also going to utilize using another tool that can help us problem solve it, and that is drawing a picture. More specifically, we're going to be using a box diagram. Do you guys remember when we did box diagrams originally? Does anybody remember what they looked like?
Yes and no.
Yes and no. It was ages ago, right? A box diagram. Well, I'm going to refresh your memory on a box diagram, and we're going to use the diagram to help visually display our addition and subtraction problem. So without further ado, let's take a look at today's problem.
Yay.
Voila! It's Pepper again! Pepper made an appearance in our word problems today. So Ms. Velez takes Pepper for 2 walks a day. She walks 1 9/10 miles in the morning after her Block A class. Her fiance John then joins her and Pepper for a 2 3/4 mile walk in the afternoon after her Block C classes. What is the total distance Miss Velez walks with Pepper? So there's me on walk 1 and walk 2 with Pepper. And yes, I have to carry him. His little paws can't hit the sidewalk just yet. He won't have all his vaccines till January. So for now, when I have to take Pepper for a walk, I have to carry him like a little baby in a bag. All right. So there we go on our walks. And I want to know the total distance that I'm going to be walking with Pepper. What operation am I going to need to use to solve this problem? What operation?
Yay.
There are only 4 choices.
Multiplication?
No.
Read it carefully.
Division. No, subtraction.
This was.
Oh, we're just shouting all of the operations out. It's addition. What word tells you it's addition?
I don't know.
Total.
Total. We're finding the total distance. So we're going to have to take, guys. So we're going to have to take the 2 distances. So we have 1 9/10 miles. And we have 2 3/4 miles. Now, 5th graders. When we are solving this problem, I need us to set up an equation. How would you set up an equation to solve this problem?
Finding the common denominator?
Not yet. I just want to set up the problem. So what do I need to write? I need my operation in there. What do I need to write?
Plus.
Oh, I see Ashley's got it up. We're going to have to add, right? We just said it. We're going to have to add 1 9/10 miles was the first walk, plus 2 3/4 miles is the second walk. Now, we're finding a total. When we are finding when we're writing an equation, you must have an equal sign in it. Okay? In order for it to be an equation. If we do not know the value just yet, what could we put after the equal sign?
0. Question mark. Question mark.
Question mark, or let's get a little fancy with it. What could we put we could put a variable. In this case, I'm going to put M, and it doesn't matter the letter. I'm going to put M to represent the total miles. Now, for those that forgot what a variable was, it's basically the same thing as a question mark, okay? It's a letter that you put to represent an unknown value. So we don't know how many the total miles are, so we're going to put M as our variable to represent that unknown value. Now, if you just write this, it's not an equation because it does not have an equal sign, doesn't equal anything. If I write, and I lost my eraser yet again. If I write something like 1 plus A equals 3, I could solve this because I have an equal sign, so I can tell, okay, what is A going to be?
2.
It's going to be 2. 1 plus 2. Why? Because I have an equal sign. I have written an equation. If I just wrote 1 plus a, could I solve that?
No.
No, I don't have an equal sign. This, when I don't have an equal sign and I can't solve it, is called an expression. If I have an equal sign and I have a value I can find, it is called an equation. So if I ask you to write an equation, you need to make sure that you have an equal sign. If I'm just asking you to write an equation, you don't have to solve it just yet. I just want to know that you know how to set up the problem. So you can put a variable, any letter of your choice, as the unknown value or your question mark. I don't know what it equals yet. I still have to figure it out. So I'm going to put a letter. You can use M for miles, or you can use any other letter. It's usually written lowercase and kind of has a curve to it so that we can identify it clearly. So here's our equation. We have the 1 9/10 miles plus the 2 3/4 miles, and we want to find the total amount of miles. As a refresher for setting up our box diagram, you may recall that box diagrams can only show one operation. So if I had, just as a refresher, 1 plus 2 equals
3.
well, I'm going to put a variable because I haven't solved it yet. I'm just writing an equation, didn't solve it yet. I would represent that on my box diagram by drawing 2 boxes. There are 2 values that are being added. So the 1 is being added to the 2. Does anybody remember how to draw the equal sign on your box diagram? Anyone?
You draw like, I know how. It's like you draw like another, like, it's like the top half of a box on the top. And
Yes.
it's like the top half, and then like you put the answer there.
Correct. So this kind of looks like a little football field, like the 1 yard plus 2 yard, and then you kind of have your end zone for the foot, and that's your equal sign. And on here, you would put M. So 1 plus 2, they're together in the box, would equal M, and I can solve it. So my box diagram can only show addition. And if you forget, there's a little addition sign.
Wait, it can't show multiplication?
Well, you have to tweak the way you design the box in that case. I will show you. Yeah. So, but it only shows addition, and then everything else we're going to have to switch up, and we'll get into that in a minute when we look at problems that are not addition. For now, you just need to know that all box diagrams show addition. If you needed to do multiplication, you would do repeated addition, and so on and so forth. So this being said, with our box diagram and moving on, now we have these 2 values. What would I have to draw to make this box diagram? Let's hold up our whiteboard. Let's see if you know how to draw a box diagram for 1 9/10 plus 2 3/4. Everybody hold up your whiteboards.
Oh, your white?
Whiteboards.
I need to draw the what do you do? Your box. I said box.
Okay, so well, the first thing you're drawing is your box. And then how many things are you adding?
2 things.
So you need to do how many boxes?
2.
2.
Where do you put it like this? I already did the math. Sorry.
Let me see. Yes, exactly. So we're going to draw 2 boxes. I see some people holding it up. Good, Dominic. I saw good. Ashley had it.
Putting it up.
Kai's got it. Good. Zoe's got it. All right, Jaden's got it. Good.
Okay.
All right, so 5th graders, we're going to draw our 2 boxes for the 2 values we're adding. So we have the 1 9/10 together in the box with the 2 3/4. And then we're going to put our equal sign, which is kind of like our end zone lines. And that it equals M because we have not solved it yet. So I put an M there. Now that I have my box diagram, we are awesome. This box diagram, even if I didn't have this equation up here, if I saw this, I would know, oh, 1 9/10 plus 2 3/4 equals M. So you should know both ways around. You should know how to read it forward and how to kind of read it backwards in a box diagram. If I showed you this picture, you wouldn't say like, what is that? You would say, oh, that's an addition problem. 1 9/10 plus 2 3/4 equals M.
Well, that's not really backwards though.
It's not backwards. You're right. It's just a different way of visually representing it. You're right. Okay, so now that we have our box diagram, let's actually add. And to add, we want to line up our numbers vertically. 1 9/10 plus 2 3/4. All right, the first thing our eyeballs go to is
Divisor.
divisor. All right, and we notice they're not the same. We're going to have to rename. Bring over my whole numbers because I'm adding, so I don't need to borrow, so I don't need to worry about changing my whole numbers. But my fractions, my proper fractions are going to have to be changed. We need to find a common denominator. Should we start with the 10 or the 4? The 10. So let's go. 10, 20. Stop. Good. I don't even need to write it. I should be doing it in my head. Who did it in their head, found the common denominator?
I knew it was 20.
Good, good. That's the goal. That's the goal. The goal is to not have to write it again and again. Hopefully you started with the 10, you said 10, 20, got it, and you wrote it immediately. 20 is our common denominator.
But the thing is, if you kind of just look at it, it's kind of already like simple.
Right. I just don't want any careless mistakes. Remember, I told you that's like the #1 mistake that I get, careless errors. All right. How do I get from 10 to 20?
2 times 2.
Give me directions here. Times 2. Whatever I do to my denominator, I do to my numerator. 9 times 2 is?
9 times 2 is 18.
18. Awesome. How do I get from 4 to 20?
4 to 20 is
Times 5.
Thank you. Times 5. Guys, come on.
You called on him.
All right. Times 5 at the top as well, and we get
15. I have the answer.
All right. So let's add them. Oh, I hope you may see a little dilemma here in a minute. 18 plus 15 is what?
33.
33 over 20. And 1 plus 2 is?
3. But you can simplify it.
5th graders.
1 plus 2 improper.
Improper.
Okay. All right. So a lot of you already saw it. My numerator is greater than my denominator. I put on my monocle and I determined that's improper. We're going to have to fix that.
Just like Johnny Bravo.
Exactly. It's a Johnny Bravo fraction. There's an imbalance here. So I'm going to write my 3 because I don't want to forget it, but I have to do something with this. I cannot keep 33 over 20. I'm going to have to divide. So 33, the number on top, the numerator goes inside the house. 20, the denominator goes outside. 20 goes into 33 how many times? Once. How many remainder?
13.
13 and
over 20.
Keep your name. Keep your denominator.
It's 4.
1 and 13 20ths. Good. I'm not done though. I need to add the 3. 3 plus the 1 is
4
and
13
20ths.
In simplest form.
That's it.
13. Wait, 13.
Who was able to change the 33 20ths into a mixed number in their head?
Me.
In their head. Can everybody see that? By now you should be, I wrote it out for you here, but by now you should be able to do that kind of up here, right? 33 divided by 20. 20 can only go into 33 one time with 13 left over. So it's going to be 1 and 13 20ths. Add that to my 3 and I get 4 and 13 20ths. The goal is to strengthen those mental math skills. All right. So how far did I walk with Pepper? 4 and 13/20ths of a mile.
That's a lot.
That is.
Is that true?
No, I walk that far on my own, but Pepper is a little too young if he's not able to go potty
So
to actually walk that far. So
are
I have
you
to
an
go for
athlete?
shorter walks. What was that?
Are you an athlete? Like
I like
just
jogging and walking. Yeah.
Okay. Are you sure you're an athlete though?
I'm not an athlete.
You're not a famous
Aw.
football player. You're a burrito athlete.
I like burritos too much to be an athlete.
Well, Miss Lynn,
No
man, you jog 4 miles a night in like 13,
Well,
20
no,
so-
if you combine through a day, you
have
can get
a
those walks in.
question.
All right, we're going to move on.
I
Yes,
feel
yeah.
like in
Move on.
COVID, all teachers are athletes, though. 'cause
Oh.
it's like really hot.
I have a question.
Thank you. Yes.
Would you give up burritos to be a millionaire?
That's really hard. Oh, I don't like that question.
All
All right, let's move on. Everybody needs to be on page 2. Okay, guys, we got to move on. Page 266. 266.
in our
Are you
math
with me? Yes,
or-
in your textbook.
Oh.
All right, so if you look at page 266, you have a photo of a hiking trail. And the question says that Jesse hikes all 3 trails. So we have the wing trail, which is 2 3/4.
Okay.
We have the sunset trail, which is 1 7/8 of a mile. And then we have the ridge trail, which is 1 1/3 of a mile. If Jessie is hiking all 3 of these trails, how far will she hike? What operation am I going to need to use to find out how far she hikes? Addition, because we're finding the total amount of miles she's hiking. So I'm going to have to add. Do I have my equation fully written?
No.
What do I need to add?
No.
You need to add 2 numbers first.
I have my numbers. Why is this not an equation yet? What
You
needs
need
to
to
be
put
written?
the equal sign.
I need an
You need to put
equal
the
sign
equal
for an
sign.
equation. Do I know what it equals yet? No.
No.
Let's put a variable.
What
I
letter?
think we'll use M
A.
again. Well, let's
A.
use M again because it's miles. But you can use any variable. You can use any variable you want. So now we have our equation: 2 3/4 plus 1 7/8 plus 1 1/3 equals M. Now, box diagram time. How many boxes do I need to draw?
3.
3. There are 3 values. 1, 2, 3 mixed numbers that I'm adding. The 3 values I'm adding need to go into 3 boxes. 2 3/4, 1 7/8, and 1 1/3. Awesome sauce. I'm not done. Where do I put my equal?
On the top.
On the top. Yeah, it's a weird equal sign. It's like goal. So here's our equal sign, and we don't know the value yet, so we're going to put a variable equals M. So if you saw this, would you know that that's an addition problem?
Yes.
Yeah. Would you be able to write an equation just by looking at this picture?
Yeah.
Yes.
Yeah, because it's always addition, right? So 2 3/4 plus 1 7/8 plus 1 1/3 equals M. Just by looking at this picture, I should know how to write an equation from it. And by looking at my equation, I should know how to write a picture. You should know each way. All right, now that I'm done drawing my box diagram, I can visually see what needs to be combined together. Yes, do you have a question? What's up?
That's not a question. I just want to solve it. I already got
Oh,
the
you want to
answer.
solve it? Excuse me. All right, everyone has their box diagram. I'm going to erase Ashley jumping ahead of us. Shh.
What? You taught me it, now I want to do it.
Answer.
All right.
Can I get
We don't have any
diagram?
parentheses, but we have, yes, you may. We don't have any parentheses. We have 3 different mixed numbers, but we can only solve 2 values at a time. So let's solve this first. 2 3/4 plus 1 and 7/8. Remember, if there are no parentheses, you always solve in order of first to last, as long as we have addition and subtraction that we're working with. All right. First thing I look at are my denominators, and they are different. So I'm going to have to rewrite. We get 2 and 1. We keep our whole numbers. What is going to be our common denominator between 4 and 8?
8.
8.
Correct. Hopefully you see it right away. 8. No need to write everything out. We're experts at this point. How do I get from 4 to 8?
Times 2.
Times 2. Whatever I do to my denominator, I do to my numerator. 3 times 2 is 6. All right. 7/8.
Improper fraction.
7/8.
Plus 6/8 is wait, that's
What
do I do?
It's 14.
1 and 14.
Whoa, whoa, whoa. Shh. You're skipping ahead. What do we do?
Times 1 is 7.
All right, I'm going to
still.
mute us because we're all talking over each other. All right. 5th grader 7/8 does not have to be renamed, only rewritten, because 7/8 is the same as 7/8. No need to do any kind of renaming there. All right, let's add our fractions first. 6/8 plus 7/8 equals
13.
13/8. 2 plus 1 equals 3. Again, I look at my fraction and I see that's improper. Our numerator is greater than our denominator. So we're going to have to divide. So I'm going to keep my 3 so I don't forget it. But my 13/8 is going to have to be 13 divided by 8, which you might be able to do in your head. Who can do that one in your head without writing it out?
Can I say the answer?
What is it?
1/5. 1/8.
Right. So the 8 goes into 13 only one time, and then find your remainder. 13 minus 8, 5, and you always keep your denominator.
And then
1 and 5/8. Don't forget to add it to your 3. So we get
1 is 4 5/8.
4 and 5/8. Am I done?
No.
No,
Not
we
at all.
only did this. We still have to do this. So let's keep that 4 and 5/8. I'm going to erase, but you can continue down your page. All right. 4 and 5/8, 5th graders, and 1 and 1/3. And we're going to add them. Okie dokie. Look at our denominator first. They're not the same, so we're going to have to rename. 4 and 1 stays the same. What's our common denominator?
24.
Yes, Seraphin. 24. Good. Hopefully you started with 8 right away and arrived at that common denominator. Let's rename. How do I get from 8 to 24?
Times 3.
Whatever I do to my denominator,
Numerator.
times 3, we get 15. Yep.
I just write it out as like 3 fractions and just sort of add them like
Well,
that.
with
Find the
addition,
common denominator.
As
And
long
then
as it's
just
addition, you could do
figure
that.
out.
Yeah. As long
Yeah.
as it's addition, you can do that. That's
Yeah,
for
you
sure.
can- Wait.
All
Yeah.
right. So how do I get from 3 to 24?
Times 8.
Times 8 times 8, and we get 8/24. All right, let's add them. 15 plus 8.
Is 23.
23. Gosh, isn't that close?
Yeah.
That's so close. And don't you just want it to be a whole number? 24 out of 24. And 4 plus 1 is 5. So our final answer, 5 and 23/24, but that's solving the equation, not the problem. So that being said, how far will Jesse hike in total?
5 and 23/24 is almost a whole. Wait, no.
Basically 5 miles and
5 and
quarter.
23/24 miles. Miles. You're solving a real problem, not just an equation. So you need to make
basically like
sure
a
you
mile.
include your units.
Basically 6 miles.
I know, basically. It's like, come on. Really?
Why can't it be 6 miles?
Right?
Just make it 6.
Make it
Just
6.
make it 6. I'm
Wait,
going to keep this up.
Isn't this about 6? Like, this is technically 6.
Right, but if we're getting specific, let's say she wants her stats
Specific.
for traveling. We got to
About 6
be like,
miles.
I walked this much. I hiked this much. All right.
Who wants
Now,
to know?
if you notice, if you look carefully, the next question actually goes together with this one. So I'm going to keep this value of 5 and 23/24. Now we have another hiker. Kent only wants to hike the wing trail. How far is the wing trail? Look at your chart. How far? Look at
2
your
and
chart.
3/4.
Thank you, guys. It's right on your book. I didn't. 2 and so this is how far the wing trail is. 2 and
Wait, we're on
3/4.
page
266. 266. So that's how far the wing trail is. Yes. And now they want to know if he's only going this far. We already know how far Jesse went. How much farther will Jesse hike than Kent?
So
What operation is that?
subtraction. Wait,
Subtraction. You have a compare word in there. What's the compare word?
farther.
Farther. And whenever we compare, we're finding the difference between two values, which means we're subtracting. So we have
Or
to take
division.
Jesse's distance and we have to take Kent's distance and find the difference. So what should my equation be?
5 23/24 miles minus 2 3/4 miles equals
Oh, you're on a roll. Equals what?
M.
M. And it could be any letter you want.
It
But
could
yes,
be-
make sure you have the equals. All right, make sure you have the
Can
equals.
it be pi next time? Okay.
All right, so we have our subtraction here. We have our equals. Now we've got our equation solved. There's only one dilemma. If I draw my box diagram, dum, 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 what operation did I say is the only operation that can be shown in a box diagram?
subtraction.
Addition. Addition.
But what do I
Yeah,
have?
well, subtraction.
Subtraction.
So I can't just do this. I can't just do this.
You cannot at all.
Wait, that's wrong.
Because this means 5 and 23/24 plus 2 and 3/4. I have a subtraction problem. So my question to you is, on your whiteboards, how do you think you would draw this?
I don't
Now,
know.
hold up your whiteboards. I'm going to see who gets the closest. Nobody in the last group got it. I will say that.
Nobody.
Nobody. I had some interesting approaches, though. I will say very clever approaches, but
can't
it is
draw.
a challenge. What do you think
draw.
on your whiteboard? On your whiteboard, how do you think you would draw a subtraction
It's gonna be a little
problem?
bit messy, but like.
If,
Wait, I know.
remember,
Okay.
okay. Remember,
This
a
is
box.
my-
A box diagram can only show
Like this?
addition. You need to put your numbers in your boxes. I need to know. It's gonna still look like this.
You can't do it.
Yes, you can.
Can you?
I'm gonna wait. I'm gonna wait.
Here you go. Like this?
Let's see. Interesting, but not quite.
Wait a minute.
I tried my best.
Did you just put it upside down?
Maniacal laugh. I
Yeah.
should have dressed as the Grinch today
The
because
only thing
I'm
I did
feeling
was turn
evil.
it
Can't get
upside
it.
down.
This is evil.
That
The
could be-
Grinch is evil.
Like the
Wait.
I got it.
Anybody have it?
I did
Nope.
that, Valentino. Valentino, I did that.
Let's see. Anyone else?
Got it.
Nope.
Did
I
I
love-
get it?
I love the efforts though. Nope. No one's gotten it yet. Oh, I will
Wait,
say
look.
someone may have gotten it.
Who? Tell us. Tell us.
All right.
They're just
Boards down. Boards down. Boards down. Seraphim. Got it.
I knew it.
Wait,
So,
I wrote
okay,
it
keep
down
your
too.
board down. So 5th graders.
It was me.
I know. Did someone else have the same thing?
Yes.
Yeah, who had it?
I have M, and I have this, and then I have
Okay,
5, 22.
So listen.
I had this.
Listen. Since the box diagram can only show, it can only show addition, and I have a subtraction problem, I'm going to have to make the subtraction problem into an addition problem. Huh?
What?
I know, gasp. It's possible. Watch, just watch. So let's start with some easier numbers. Let's say I have, just watch. Let's say I just had,
Science.
I'm gonna wait. I'm gonna start with easy kindergarten numbers. Watch me.
Yay.
3 minus 2 equals 1. Watching. I'm gonna turn this magically into an addition problem. 3 minus 2 equals 1 is the same as 1 plus 2 equals 3.
Oh, that makes sense. It's a fact family. It's unit property.
You are using the inverse operation. 3 minus 2 equals 1 is the same as 1 plus 2 equals 3. So if I have 5 and 23/24 minus 2 and 3/4 equals m, how can I turn that into an addition problem?
And that means that
Who has the addition problem? I know, our brain hurts. It's true though. Isn't it true? 3 minus 2 equals 1 is the same as 1 plus 2 equals 3. You're just switching around.
My
Right?
brain
Well-
is hard to process.
All right, watch again. Watch. Magic trick. Watch. So the biggest number, I'll wait. I took the biggest, I'm going to wait. I had a giant number 3 and I took a smaller number of 2 away and I had a remainder of 1. If I add those 2 smaller numbers, 2 and 1, I will get 3 again. It is an inverse operation. The same as if I had 5 minus 2 equals 3 is the same as 3 plus 2 equals 5. Notice I'm just going backwards. 3, 2, 1, 1, 2, 3. 5, 2, 3, 3, 2, 5.
Wait, what
switching.
do you put it like this? So this one would be addition and this one would be subtraction? Barely
Yes, you got it, Ashley. So in this equation, I'm still waiting for someone to actually give me an equation that is an addition problem. How will I change this into an addition? I keep saying an addition problem. Making,
Wait.
what's my addition problem?
Look at the problem. Look at the problem. Look at the problem.
What's my addition problem?
Okay, so then.
3.
Of this.
Of that.
I didn't say you had to solve it yet. I just want to know what the problem would be, which means
Can I solve
since we
it?
didn't solve it, you would use your variable. Let me see.
It'd be 5 and 23.
All right, well, you're
23,
you're turning, Jaden, you just changed your symbol. So 5 minus, let's round it. 5 minus 2 equals 3 would be the same as, go backwards. 2 and 3/4 plus whatever this is should give us this.
Wait, what?
Oh, you have to.
Look, 5 take away 2 will give us this, which
Oh
means
my
whatever
God.
this is plus 2
Oh,
will give
wait, I
us
know how
this.
to make him.
It's so obvious now.
See? Now, all I have to do is plug my numbers in to my chart.
And it's
Whatever-
3 and
what's
5,
being-
24.
You have to add 20 to
So
each, though.
these 2 are being added now.
Easy.
2 and 3/4 plus m, and it's going to equal
5.
5 and 23/24.
Because you have to add it by 20.
It's so obvious now.
Do you see it now? So you're just switching it around. 1 plus 2
okay.
equals 3 is the same as 3 minus 2 equals 1.
What you have to
You're
do with
switching your numbers around. You're using remember, an inverse operations can undo another operation.
You have
So-
to basically add the number from the first problem to add it to the second problem.
Right.
We just
So
went
whatever you took away, you're going to add the 2 parts to get your bigger number. Okay?
It's just a trick question, basically. But
It's not a trick question. It just means you can only show addition in a box diagram. So if you get a subtraction problem, you're going to have to change it into an addition problem.
Wouldn't it be like what is it called? Division, but like not division?
If you did division, you're going to have to also try and switch it into an addition problem. Yeah. All 4 operations, addition, subtraction, multiplication, and division, can be shown on a box diagram, but you're going to have to change all of the other operations into some form of addition. So for now, baby steps, we'll start off with addition and subtraction. In the next chapter, we'll look at how to change multiplication and division into a box diagram. I know. So let's solve this really quickly. 5 and 23/24 minus 2 and 3/4. 5th graders, I already eyeballed it. And we have 2 different denominators. What will be my LCM?
24.
So
yeah,
guess
24.
what? If it's 24 on both, what happens to my 5 and 23/24?
3 and 5, 20.
They're the same. You just have to rewrite them.
You rewrite it. It's the same thing. The only one that's changing, that's being renamed, is the 3/4. How do I get from 4 to 24?
Times 6.
Times 6. Whatever I do to my numerator,
You do it
I
to
do to my denominator. 3 times 6 is?
12.
3 times 6 is?
18.
Okay, gosh. I couldn't write that any slower. All right, 5th graders, let's subtract. 23 minus 18 is? Minus.
5.
You sure?
Yeah.
No, it's
No,
It's
23.
13. No,
Oh,
wait,
yeah.
you can't do it. Wait, yes, you can. 13?
No.
13.
He's
13.
correct. I was just testing you because only one person answered.
Because you have to put the
5
3
minus
up,
2 is?
and then you have to minus
Oh.
Okay, 5 minus 2.
Something.
3.
Oh my gosh, one person today. Is it in simplest form?
Yes.
And we're
Yes.
solving the
So.
problem, not just the equation. So what do I have to add to my answer?
Yes.
Something.
Miles.
Miles. I need to
happening?
add my units. So 5, 3 and 5, 24ths. So 5th graders, so you all know how to do a beautiful box diagram now. And you know how to visually represent addition and subtraction. So hopefully you can do that with all whole numbers, mixed numbers, fractions, and eventually decimals. You can all use them in a box diagram. All right, any questions? Are we good to go? Yeah? All righty. So you have some more practice with this tonight. Well, for tomorrow, you've got practice problems in your workbook on practice page 10-7. So you can practice with those in your workbook first and then transfer them to the Google form, and make sure you show a copy of your work, because I do want to see your box diagrams, which you're not drawing on the form. You're going to draw that in your notebook.
Wait,
All
you
right.
can draw on forms?
You can't. That's why I want to see a picture of your notebook. So I
Miss
can see your,
Velez.
Yes.
At 4.
Hi.
All right,
Miss
guys.
Velez,